if you can see my screen there, so this is binomial theorem. So we're going to expand the one on the left, a plus. First of all, do you see the difference between, what's the difference you notice between that expression there and that one on the right? What's the difference? So you can see this one has got power to the power 4, and that one has got power n. Okay, that one, the one on the right, to the power of n, we need a formula. We need a formula like this to be able to solve it. Okay, to be able to expand it. But this one also, we will need. We could also use the formula, but it's a quicker way for us to solve the one on the left. So that's what we're going to do today. All right. Without no further ado, we're just going to dive into it. Okay. So remember, the one on the right with power to n, you can use these formulas I've shown you there, the normal formulas for binomial theorem. Then the one on the left, you can also use the formula, but there's a quicker way to solve it, and that's the aim of this video. All right. So I'm going to stop sharing. I'm going to stop sharing and just show you my visualizer. And just going to go to my visualizer there so you can see what I'm going to do. Okay, hopefully you can see it clearly. Hopefully, we just make sure it's all clear here. All right. So like I said, this one, all we have to do is use a different method instead of the formula. The formula is a bit murky and quite long. All right. So we like to keep it nice and easy in Mr. Chika tutorial class. So here we use a Pascal triangle. With a Pascal, if you remember your Pascal triangle, right? It's like the golden rule of mathematics. Okay. That's another topic for another day. But Pascal triangle, it starts with 1, and the next bit with 1, 1, okay? And the next bit will be 1, that plus that will give you 2, and then 1, okay? And the next bit will be 1, 1 that plus that, 1 plus 2 is 3, 2 plus 1 is 3, and then 1, okay? And it's to the power of 4, so we just want to get up to the fourth one. So that will be 1, 1 plus that will give you 4, 3 plus 3 give you 6 there, then 3 plus 1 will give you 4, and then 1. Okay, so when I have a power like that, like 4, I'll be able to use parts of a triangle. Okay, so here to expand that quickly, I'm focusing on this. So these are my coefficients. These are my coefficients for if I expand that, that's going to be my coefficients. Right, like so. So that will be equal to, so that equal to, I like to space it out for me to be able to see it. Okay, space it out. So the first one is 1, then the second one is, I'll add 4, and then the third one plus 6. You see where I'm going with this? Then was 4, and then the final one is plus 1. Okay, now to expand, so if I'll times with a to the power of 4 and b to the power of 0, okay, like so. So I will start with a to the power of 4 and b to the power of 0, okay? And then the next bit will be a times a to the power of 3, then b to the power of 1. So you can see here, the a variable, the power of the a variable will start decreasing, whereas the power of the its b counterpart will increase. Okay, a will start, the power of a will start decreasing, while b will start increasing. So the next bit now, you already guessed it. So it's going to be 6 times a to the power of 2 decreasing, and then b will now increase to power of 2. Okay, and then we have 4 times a to the power of 1 and b to the power of 3. There's a times there. All right, and then the final one, 1 times a to the power of 0 and b to the power of 4. So if you tidy that up, 1 times a to the power of 4 times b to the power of 0. Anything power to the power of 0 is 1, isn't it? So 1 times a to the power of 4 times 1, which is going to give you a to the power of 4. Then plus 4 times a to the power of 3, that's a to the power of 3. Anything power of 1 is the same thing, all right? Plus 6 times a squared, b squared, plus 4 times a to the power of 1 is a times b to the power of 3. And finally, 1 times a to the power of 0, anything to the power of 0 is 1, so that's 1 times 1 times b to the power of 4, so it just gives you b4 to the power of 4, all right? So that's it. Easy peasy lemon squeezy. All right, so like I said, if I have power of 5, power of 6, I can push it. Power of 8, I can push it. If you can extend this as much as you can extend the Pascal triangle. But when you can't, when it's too long, then you use the formula. And also in the next, like I've already told you, the next one, if we have to expand a plus b to the power of n, that's when we use the formula. So look out for the next video. If you have any question, let me know. Bye for now.